Alright, so who knows what the boiling point of water is?
212.
Oh, did someone, was that the end? Did someone just answer for us?
Yeah.
Okay, I'm not going crazy. Okay, yes. Who knows? What is it?
212.
Okay, and what is atmospheric pressure at sea level?
14.7.
And what is water's boiling point?
212.
Okay. All liquids have a vapor pressure. This sounds weird, right? It's a little wordplay. All liquids have a vapor pressure. So, in order for boiling to take place, the liquid's vapor pressure must become equal to or greater than the pressure that is the atmospheric pressure or the pressure exerted on the liquid. Hold on. I got some. Okay, so atmospheric pressure exerted on the liquid's vapor pressure. Okay? If the atmospheric pressure is stronger, is it going to be able to overcome it and escape in vapor form? No. But if the vapor pressure is equal to or stronger than the atmospheric pressure, is it going to be able to overcome it? Following? Like my little emojis? Alright. So, what are some things what do we usually do to bring water to a boil?
Put a pot, a lid on the pot.
We heat it. I'm getting there, but yeah, in general, what do? We heat it, we add heat. Okay, so the heat energy actually increases the vapor pressure of the liquid. Following? Does that make sense? Okay. So, water boils. In order for water to boil at sea level, which is where we're at, what do you think its vapor pressure has to get to?
14.8.
14.7, so it can equal. Once it equals the same, it's not going to be holding it down. 14.7, does that make sense? So at 212 degrees, water's vapor pressure, this is at sea level, is 14.7 psi A. And we say it's psi A because it's including atmospheric pressure. That would be psi G on I'd be 0 psi G. Okay. So, what is something else we could do? We learned what a vacuum is, right? What is something else we could do to decrease the boiling point? So we don't have to add as much heat energy, but we can still make our liquid boil. What's something y'all think we could do?
Put a lid on. Like,
So decrease the atmospheric pressure? Well, if we decrease the atmospheric pressure to, let's just throw to 10, we pull a vacuum. So this is involving an enclosed container, right? Where there's no flow for it to go somewhere else. Does that make sense? We're pulling a vacuum. We're removing the pressure exerted on the liquid. So we decrease our atmospheric pressure to 10. Don't quote me on this. I'm just throwing random numbers out, okay? Well, now we may be able to boil at 170 degrees. We decrease our pressure. This one's accurate. We decrease our pressure to 4.5 psi. We're going to be able to boil at 150 degrees, water specifically.
You're talking about the atmospheric pressure?
Well, not necessarily the atmosphere. Yes, well,
the pressure exerted.
the pressure exerted on the liquid.
Okay.
So if we decrease it to 4.5, we're able to boil at 150 degrees.
Okay.
Okay? And if we decrease our pressure to 0, we're able to boil at room temperature. Okay, field trip. Pause it. So this is a vacuum pump. Yes, we know that pumps are used for liquids or vapors?
Liquids.
Same, and compressors are used for vapors, right? However, I don't know why they use this terminology. Same thing as at home when you have an air pump for your air mattress or your floaties. I don't know why they call it a pump. It's technically a compressor because it's for vapors. But a vacuum pump, same concept, it's for vapors. I don't know why they call it a vacuum pump instead of, compressor, but this is where we're at, okay? So it's going to suck the atmospheric pressure out of my chamber right here, okay? I have water. There's nothing special about it. It's from the water fountain. It's probably a little stagnant, but besides that, I'm gonna put it in my vacuum chamber. I'm gonna close my vent, kick it on, and I'm gonna push on it to get my seal good. We removed the pressure, right? I'm gonna let my bin off. It's allowing the atmospheric pressure to go back into it, right? Is it cold or is it hot?
Room temperature.
Who said hot?
No, I said cold.
No? You wanna touch it? You can pull it back up.
I touch it.
You touch it?
Ow.
Touch the water.
I'm just kidding.
Touch the water. You don't wanna touch the water? A little colder than room temperature, maybe? Yeah. Not hot. We didn't add heat to it, but we just made water boil. How'd we do that? Removing what?
Atmospheric pressure.
Okay, so when you decrease the pressure exerted on a liquid, what happens to it? How does it affect it?
The boiling point is slower.
Yeah, so it has decrease in pressure, decrease in,
Boiling point.
increase in pressure.
Increase in boiling point.
Good. All right. I'm sorry, I thought you were. I was trying to throw it to you. Shake it. Is it liquid or vapor in there? What does it feel like? Okay, so this is for your keyboard. Keyboard cleaner, don't huff it. Okay. Keyboard, you can go ahead and hit record on it.
I am.
Oh, okay. Liquid or vapor? Shake it. Liquid or vapor? Liquid, you can feel it. Pass it down. Liquid or vapor? Alright. Keep shaking it. But when it comes out, what is it? It's just air, right? It is compressed air. It says, caution, contents under pressure, okay? How are we keeping it in liquid form? Okay, so if we add pressure higher than, we add pressure, so you got atmospheric pressure, 14.7 psia. Let's say we increase the pressure exerted on the liquid to 28. Just throwing a random number out there. Is it gonna make it harder to boil or easier to boil?
Harder.
Okay. Makes sense? And then when it comes out, well, we're dropping the pressure when it comes out. So it's in what? Vapor form. Yeah? Okay.
So a higher pressure affects liquids by compressing them? By
It increases the boiling point. It increases the temperature that you have to get it to boil. You have to add more heat energy and increase the instead of 14.7 water's vapor pressure to boil, you have to increase it if the atmosphere or if the pressure exerted on it is 28. You're gonna have to heat the water until its vapor pressure equals 28 to make it boil, right? Or we use pressure in an enclosed vessel to keep something that's normally not liquid, air, from boiling off. We increase the pressure in a tank or a storage vessel to make it boil at higher temperatures. Anyone ever use a pressure cooker?
Mm-hmm.
It cooks it way faster, right?
Mm-hmm.
How does it do that?
Increasing the pressure.
It increases the pressure of it, increasing the boiling point, therefore we can increase the temperature of it without it boiling off.
So when that air comes out of that can, it's essentially boiling off.
It's boiling, it's evaporating.
Because of the higher.
because it's a drop in the pressure. The drop in pressure going from this can to out here it's instantly hitting atmospheric pressure, right?
So
In the can, it's pressurized, keeping it in liquid form.
So
Hey, chatty Cathy's. Hopefully every time y'all chat from now on, you're prepared to tell the whole class what you're chatting about. I'm serious.